So today we're going to put together a 64-bit magnetic memory. First we'll start putting the connectors into the fixture plate. This holds them in place so that we can more easily handle this. These things are pretty small here. Next, put on the board, which has little marks on it to show you where the cores go. And on top of this, we're going to put some superglue activator. The superglue activator will make sure that the superglue that I dip the cores into grabs quickly, so I don't have to hold them there for a long time. Next thing to do, put on the cores. This core trough is made so that it tips the cores up on end so that they're easy to grab, and then it's got a little bit of superglue here to dip them into. This makes everything well within reach, so I don't have to do a lot of moving around with my wrist. You notice that the troughs are lined up with the cores, so I don't have to twist the cores. Just put them on one by one. Now, the more accurately you do this, the easier it's going to be to thread the wires, because the cores will be in the best position for taking the wires. If these are too far off the mark, then it's going to be more difficult to put the wires on. Because as it is, they have to go in at about 45 degrees, and that's difficult to start with. So if the cores are off by more than 45 degrees, it's going to be harder. Now, super glue is just here to temporarily hold the cores in place, and it's not strong enough to withstand the wires being pushed through them. So the next step after doing this will be to lock everything down with a UV cure resin. Now the slots in the sifter plate are just a little bit narrower than the diameter of the core, so that it will tip them into it and make them stand up almost vertically, but more so than if I had to grab them out of a random pile. Every once in a while you'll see me get the core stuck to the tweezers, and I've found it's easier just to toss that one away and grab a new one rather than trying to wrestle it into place. You see the hand with the tweezers doesn't have to do a lot of movement. Most of the movement's done by the other hand that holds the fixture plate and the core sifter. That's not too bad. Typically I'd have about 4 or 5 cores that don't want to cooperate. So the next thing to do is take this UV resin and put it at each of the intersections of the core edge and the plate. This locks it down so that when I put the wires in, they're not going to move around or snap off. I'm going to be hitting it with the tweezers pretty hard. Now this also forms a little ramp at the base of the core so the wire doesn't get stuck on the flat surface of the core as I'm trying to push it through the rings. You also notice that I haven't soldered the pins of the header to the board. That's because I'm going to be soldering the wires as I put them through. and there's no reason to have solder there already. In fact, that makes it harder because now you have to have fresh flux for that wire. Okay, now that that's done, I'll hit it with the UV lamp, which will cure it in about 5 seconds. Yeah, so now this is nice and solid, so these cords aren't going to move. I can push them around pretty readily. Next thing to do is I'll wire up the verticals, which are my X lines. And the pin 1 dot is here, so that's going to be my reference point for everything. And sometimes, like that, you get lucky and the wire just slides right through. Over the short distance, it's stiff enough to do that. Now, soldering this solderable poly nylon is pretty easy. You just turn up your iron to about 480 C, and you apply heat to the pin and the end of the wire, and that will melt off the insulation, and the copper underneath is nice and clean, so you don't have to worry about it being oxidized. So you don't need a lot of flux. Just the flux that's in the solder will do it. And you just watch it, and as soon as the solder crawls up the wire, you know that it's soldered. Now the opposite end, I'll just trim that off for now, but I won't solder it. I can do all those later at once. So feed in another wire. Solder it. Now the fixture plate holds these connectors in place pretty solidly, so you don't really have to worry about melting the connectors when you're applying the heat. So you can take your time and get enough heat to tin this wire. And you can already see how the resin forms little ramps, so the wire just slides right up into the hole of the cores. Every once in a while you have to coax it in there. Now something I also do is when I go to cut this wire, I'll actually pull it to straighten it back out for the next run. In case you're wondering, no, I never do wipe my soldering iron off on a sponge. In fact, I don't even have a sponge. I think the last time I did that was somewhere in the 70s. every once in a while you'll hear me tap my iron in a little tray I have. So I don't sponge it off, I basically knock off the excess solder. So flip this around and solder up the other ends. Now I'm not going to worry too much about the placement of the wire, because what I'm going to do afterwards is reheat the joint while holding the wires down. It's easier to do it this way than to worry about it while you're trying to solder the wire in the first place. That's all the X wires. Now we're going to flip it over and do the Y wires. These are the ones that run horizontally. And as you can see, the resin on the cores makes them completely immovable. So I can go in there with my tweezers pretty aggressively. Something you can't really see from the video is that I'm doing all of this under a binocular microscope. In addition to making it easier, my eyesight is not really good enough to do this without some kind of aid. But a good binocular microscope from a place like Amscope is cheap enough that there's really no reason not to give this tool to yourself. This one's going to be a little uncooperative, but that's okay. Now the X and Y wires, I'm just using straight off the roll, so I'm not pre-cutting the wires at all. That's an extra step that I just don't need to do. The enable and the sense line, however, those have to be pre-cut because they have to be threaded through, and you don't want to have to be fighting with the roll while you're doing that. Now, the reason I'm doing them in this order, X, Y, enable, and then sense, is when the cores are relatively empty, it's good not to have a lot of wire to fight with. And as you put more wire in, it gets harder and harder because there's less space in the hole. The sense line is the easiest because as opposed to going in at 45 degrees like the rest of the wires, they go perpendicular to the core face. So that makes them the easiest as possible. So this is now the enable line. This has to go through all the cores, and it has to go in with the same polarity as the X and Y drive lines. Now you want to cut off about 12 inches for the enable line and for the sense line, which is way more than you need. But if you bend up the front end of the wire, you're going to want to snip that off and have some fresh wire. You don't want to be trying to shove a bent up piece of wire through these holes. Nobody will enjoy that. I flip it around, and I'm always going left to right because it's just more comfortable being right-handed. Just pull that right through. What you want to do is keep from scraping this wire. So use a pointed tool like this to kind of guide the wire in. Now these cores are non-conductive, so scraping off the insulation is not really a big deal. You just don't want to do it so much that two adjacent wires will touch each other where the insulation's been scraped off. So you want to just watch out for that. You'll notice that I pull the wire straight every time I reuse it. If it gets too wrinkly on the front, I'll just cut it off and expose some fresh straight wire. Just push these wires down, makes it a little easier. first time I did this, it was without the resin holding the cores down. And I spent half my time just dealing with cores that I knocked over from the tweezers. Okay, now it's all the way through. We can trim it off and solder it. Yeah, you really just want to watch the insulation on the wire. As soon as it's melted through, you can see the solder creep right on up there. Okay, so the last wire is the sense line, which is the easiest. Usually what I'll do with this one is I will run it backwards, because this is the start point right here. I'll run it backwards rather than have to fish out the entire length of it. But you see, this wire goes through really easy. Because we're not encountering the edges of the cores, which increase the friction by a lot. Now, these are actually pretty easy to figure out. You come around and you always go around in a counterclockwise direction, and you just loop around until you see the next flat faces. Now this is where a tool like this comes in real handy, because you can keep the wire from snagging, and so it goes in nice and smooth. Okay, so here's the next set of flat faces right next to it. Put this tool in here like this, and then I can just pull the wire against its rounded surface. It doesn't let it scrape on the edges of the cores. Just push these guys down. Now you notice that this one's already filled, so now we go down to the next flat face, which is down on this row. Getting a little ratty in the end, so just trim that off. It's a nice, fresh, straight wire. Again, this one's already occupied, so go down two to this one here. You'll find that these cores are actually pretty tough. I've built a lot of these and I haven't broken a core yet. I've tossed a lot because I've got them stuck to the tweezers with the super glue, but I haven't actually damaged any of them. And that's it for the sense line. So after doing this, I will give these a good cleaning, clean the flux off. You see, I can be pretty aggressive with these as well. The cores aren't going anywhere. You'll see little black pieces of plastic that have been burned off the wire. You really don't have to worry about that. It doesn't do anything. But also, it's not going to wash off with any kind of flux remover because it's not soluble in any of these solvents. Okay. So the last thing is to essentially pot this assembly with resin. And what I'll do is I'll inject this resin underneath the wires in each of the intersections. And what this does is it keeps you from getting bubbles in there. Because if you pot it from the top, you're going to trap air underneath the wire, and it's going to be really hard to get out. So by injecting it under the wires, you kind of avoid that. And this is some fast cure resin that I get from Amazon, and using a UV flashlight, it snap cures in about 5 seconds. And after these cores are potted, this assembly becomes pretty much indestructible. So I just go through and fill each intersection and then come around and cover the entire outside edge as well. And even if you're building just one of these assemblies, do yourself a favor and make a fixture. You don't want to spend your time keeping this thing from moving around. You want to spend your time doing the wiring. And the fixture is just 4 socket strips. Epoxied down to the board, and then that whole thing mounted to the aluminum plate. This gives it some weight, so it gives it doesn't move around a lot, and it gives it stability so it doesn't tip over. And we'll just hit this with a the flashlight. You want to get it from a lot of different angles because this stuff only cures when it sees the light. So if it's in the shadow, it'll stay liquid. And the last thing to do is to get it out of this fixture. These pins are actually pretty tight. So I have a pusher plate that goes underneath. There's holes underneath this that line up with the plate. That just allows me to pop it off like that. And you can see this fixture. It's got the connectors, and there's epoxy in here that holds everything still. And then it's got the 4 holes for the pusher plate to come through. And that's how you do it.